Hello friends, now we are going to prove the next very important theorem from this chapter to find out vector equation of plane. So vector equation of plane passing through three non-collinear points, A having position vector A bar, B having position vector B bar and C having position vector C bar is given as R bar minus A bar dot B bar minus A bar cross C bar minus A bar is equal to 0. So in this case plane passes through three non-collinear points and here points are denoted by A, B, C. So A, B and C are three non-collinear points in the plane which already we have shown in the figure, and whenever we are finding equation of plane we are considering any point on the plane. So let us denote any point on the plane by R and its position vector I am denoting by R bar. So in this formula this R bar is nothing but position vector of any point, be any point on the plane passing through three non-collinear points. 3 points A, B and C. So the plane passes through these 3 points A, B, C. If we are taking here cross product of AB bar and AC bar, we will get a new vector. Which new vector? AB bar cross AC bar. This AB bar cross AC bar is a vector which is perpendicular to AB bar also and AC bar also, or we can say that it is a vector perpendicular to the plane of AB bar and AC bar according to definition of cross product. We know that if A bar and B bar are any two vector, then A bar cross B bar is a new vector which is perpendicular to plane of what? A bar and B bar. So here AB bar and AC bar are two vector, then their cross product is a new vector which is perpendicular to the plane of AB bar and what? AC bar. So here we can say that therefore AB bar cross AC bar is a vector perpendicular to the plane. In this case plane is only one plane is given to us. From this we will come to know that it is perpendicular to this plane. If it is perpendicular to this plane, if this vector is perpendicular to the plane, means it is perpendicular to all the vector lying this plane, and one of the vector in this plane is what? AR bar. So therefore we can say that AR bar is perpendicular to which vector? AB bar cross AC bar, isn't it? And we know that if two vectors are perpendicular, at that time it implies that their dot product will be equals to 0. So AR bar dot AB bar cross AC bar will be equals to what? 0. Since these two vectors are perpendicular, that's why we can say that their cross product will be equals to 0. If we are not giving bracket here, so it is considerable that first we have to perform which operation? Cross product, and later on we have to find out dot product. So this implies that AR bar in terms of position vector can be written as R bar minus A bar, dot keep it as it is. AB bar in terms of position vector can be written as B bar minus A bar, cross keep it as it is. AC bar can be written as what? C bar minus A bar. On this side 0 also keep it as it is. In this way we have got required vector equation of plane. This is required vector equation of plane. Okay, so in this way we have got vector equation of plane. But generally while solving the example, instead of applying this formula, we are giving priority to another formula. Try to understand that another formula. So note, write down it as a note first. So equation, or this equation can be written as, written as. Now observe this result. Here AR bar can be written as what? R bar minus A bar dot AB bar cross AC bar, also keep it as it is. On this side 0 also keep it as it is. Now if you are taking cross product of if you are taking dot product of AB bar cross AC bar with both the terms in this bracket, what we will get here? R bar dot AB bar cross AC bar. Okay, and here again second term is what? minus a bar dot ab bar cross ac bar, which on the right hand side will become plus a bar dot ab bar cross ac bar. Means after simplifying this result we will get this term, and this is the formula generally we are applying while solving the example. So what is that formula? R bar dot ab bar cross ac bar is equals to a bar dot ab bar cross AC bar. Applying this formula we are solving the example. So second, also this equation can be written as, also this equation can be written as, if you'll observe here, first dot is there, then cross is there, means it is what? Scalar triple product. Dot and cross appears, means it is called as what? Scalar triple product. And scalar triple product is also denoted by what? Box product. So in box product, first write down r bar minus a bar, which is the second vector, b bar minus a bar, and third vector is what? C bar minus a bar. So on this side 0, keep it as it is. Means same formula is there. While solving example we are giving priority to apply this formula to solve the example. So again remember that here already in the last two theorem also we have seen that whatever maybe the vector is there whose dot product is with what? R bar. In the first theorem, what is the vector equation? R bar dot n bar is equals to a bar dot n bar. In the next theorem, what is the equation? R bar dot b bar cross c bar is equals to a bar dot b bar cross c bar. और ये सब theorem में हमने क्या देखा? R bar के साथ जिस वेक्टर का डॉट होता है, so in the first theorem its dot product is with what? N bar. What is n bar? A vector perpendicular to the plane, means it is a vector along the normal to the plane, because a line which is perpendicular to the plane is called as what? Normal. And this is the vector along what? Normal. यानी r bar के साथ जिस वेक्टर का डॉट होता है वो वेक्टर along the normal होता है. यहाँ पे भी b bar cross c bar, in the last theorem we have seen that b bar cross c bar is also perpendicular to the plane, means it is also a vector along the normal. Here also ab bar cross ac bar. What is ab bar cross ac bar? It is perpendicular to the plane, means we can say that it is vector along the normal to the plane. अगर हमें ये वेक्टर की वैल्यू मिल गई तो ये नॉर्मल पे का वेक्टर है. सो फ्रॉम दैट वेक्टर वी आर एबल टू फाइंड आउट व्हाट? डायरेक्शन रेशियोज ऑफ नॉर्मल, बिकॉज इन सम फॉर्मूलीज or some examples we have to solve applying what? Direction ratios. If equation is given to us, we should have to know how to find out what? Direction ratios, and using the formulas related with direction ratio we are able to solve the example. Okay, now we are trying to convert this vector equation into what? Cartesian equation. So let us try to find out Cartesian equation of a plane. See, now we are finding Cartesian equation of a plane. So to find out the Cartesian equation we are making the use of this result. Okay, so here r, what is r here? R is position vector of any point. Generally coordinate of any point we are denoting by what? X, y, z. So what is the value of then? R bar xi cap plus yj cap plus zk cap. And what is the value of a bar? Coordinate of point A is given to us. From that we will get a bar. A bar is equal to x1 I cap plus y1 j cap plus z1 k cap. Means if Cartesian coordinate are given to us we are able to find out their position vector. लेकिन अब ये a r bar की वैल्यू हम ओरली फाइंड करने की कोशिश करेंगे. a r bar in terms of position vector can be written as what? r bar minus a bar. अभी यहाँ पे डॉट है और बाद में क्रॉस है, यानी ये क्या है? स्केलर ट्रिपल प्रोडक्ट. और स्केलर ट्रिपल प्रोडक्ट की वैल्यू कैसे फाइंड करते हैं हम? यूजिंग डिटर्मिनेंट. यूजिंग डिटर्मिनेंट वी आर फाइंडिंग वैल्यू ऑफ स्केलर ट्रिपल प्रोडक्ट. और फर्स्ट रो में क्या आएंगे हमारे? ए आर बार इस वेक्टर में आई कैप, जे कैप, के कैप के कोएफिशिएंट्स. सो लेट अस ट्राई टू फाइंड आउट वैल्यू ऑफ ए आर बार. ओरली वी आर फाइंडिंग वैल्यू ऑफ ए आर बार. ए आर बार कैन बी रिटन एज आर बार माइनस ए बार. दिस इज आर and this is what? A. So r bar minus a bar means what we'll get? X minus x1, y minus y1 and z minus z1. So here we'll get x minus x1, y minus y1, z minus z1. Now element of second row are nothing but coefficient of I cap, j cap, k cap from which vector? AB bar. AB bar in terms of position vector can be written as what? B bar minus A bar. B bar minus A bar. ये B है और ये A है, तो इनका सब्सट्रैक्शन क्या आएगा? फिर ये B bar minus A bar बोले तो क्या मिलेगा हमें? x2 minus x1, x2 minus x1, then what? y2 minus y1, and lastly what? z2 minus z1. Observe the third vector AC bar. Let us try to find out coefficient of I cap, j cap, k cap in AC bar. AC bar means what? C bar minus A bar. So what we'll get here, after simplifying it, we will get x3 minus x1, y3 minus y1, z3 minus z1. So applying this formula, we are able to find out Cartesian equation of plane. Or if Cartesian coordinate of 3 points is given to us, this formula is applicable to find out Cartesian equation, and this formula is applicable to find out vector equation. But instead of applying this formula, we are giving priority to apply what? This formula while solving the example. By applying any formula, we will get the same answer. Is it clear? Now let us try to prove the next important formula to find out vector equation of plane. This formula is also called as equation of plane in normal form, isn't it? So vector equation of plane in normal form. So try to understand the given condition. In this case, we are finding equation of plane at a distance p unit from the origin, means distance of the plane from the origin is given to us, and this distance is denoted by what? P, and to which unit vector n bar, n cap is normal, means n cap is a unit vector along the normal to the plane. Its r bar dot n cap is equals to p. Already in last 2-3 theorems also we have seen that this n cap or n bar, whatever may be the vector is there, whose dot product is with what? R bar, is always the vector along the normal. But as it stand here, n cap is nothing but what? It is also the vector along the normal, but it is unit vector along the normal, means its magnitude is equal to 1. Now, so I'm here distance of the plane from the origin is given to us. So to find out this distance, let us draw one perpendicular from this origin on this plane, and here denote the foot of perpendicular by what? N, means ON is nothing but distance of the plane from the origin, but according to given condition, this distance is denoted by what? P. So what is our supposition here? First we are supposing that N, let N be the foot of perpendicular from origin to the plane. So therefore, since ON is a foot of perpendicular, means ON is perpendicular to the plane, and since ON is perpendicular to the plane, then we can say that ON is what? Normal to the plane, because our definition of normal is what? A line perpendicular to the plane is called as what? Normal to the plane. So therefore ON is normal to the plane. Therefore ON bar is equals to, or first write down, therefore ON is equals to what? P, because it is ON is nothing but what? Distance of the plane from the origin, but in our statement this distance is denoted by what? P. So here ON is equals to P, and we can say that n cap is a vector along what? Normal, but here ON is the normal, means we can say that this n cap is nothing but unit vector along the normal, and n cap is unit vector along ON bar. Why we are supposing that n cap is a unit vector along ON bar? Because according to given condition, n cap is a unit vector along the normal, and here ON is also what? Normal to the plane, and that's why we are able to suppose that n cap is nothing but unit vector along this normal ON. isn't it? So therefore, or this implies that ON bar is equals to, let us denote value of ON bar by what? N bar. Means we are supposing that N bar is the position vector of point N with respect to what? O. Means ON bar we are denoting by what? N bar. Now ON bar is what? Vector quantity, means it has magnitude also and direction also. Already we have written that its magnitude means length is equals to P. So on this is vector quantity, it has two things, magnitude and direction. So first we have considered what? Magnitude. Now we are considering its direction. Can I say that its direction is along N bar? According to given condition, N cap is what? Unit vector along normal, and ON is also what? Normal to the plane. That's why we can say that its direction is along what? N cap. So in this way, value of ON bar will be equals to what? P into N cap. So P is what? Magnitude. Why we are saying that P is magnitude? Because N cap is a unit vector. So since it is a unit vector, means its magnitude is 1. 1 into P is equal to P. So our first condition is satisfying, that magnitude is equal to P. अभी ON bar की direction जो है, whether N cap represents its direction. Yes, we have written that N cap is a unit vector along ON bar. So N cap represent what? Direction of ON bar. Means this side represent the magnitude also and direction of ON bar. Getting it? So once this value is known to us, now we will focus on what? Our required result. We are finding equation of plane here. Whenever we are finding equation of plane, we are considering any point on the plane. Let us denote any point on the plane by R and its position vector by R bar. So here I am supposing that let R having position vector R bar be any point on the plane. So therefore, if you observe this figure very carefully, can I say that therefore NR bar is perpendicular to N cap? So if N cap is perpendicular to this plane, means it is perpendicular to all the vector lying this plane, and one of the vector in this plane is what? NR bar. So N cap is perpendicular to NR bar, and we know that if two vectors are perpendicular, their dot product will be equals to what? 0. So therefore NR bar in terms of position vector can be written as R bar minus N bar dot N cap, keep it as it is equals to 0. Now take the dot product of this N cap with both the terms in this bracket. What will get here? R bar dot N cap minus N bar dot N cap is equals to 0. Keep this term R bar dot N cap, keep it as it is, minus also as it is. I am replacing N bar by its value. What is the value of N bar? P into N cap. So replace this N bar by P into N cap. Dot N cap is equal to 0. Write down here from equation first. Denote this result say by equation number first. Okay, now keep this R bar dot N cap as it is, minus P also as it is. Now we are finding dot product of same vector, and dot product of same vector is equal to square of its magnitude, but N cap is unit vector, so its magnitude is equal to 1. So that's why we can say that N cap dot N cap is equal to 1 square. So therefore R bar dot N cap is equals to 1 square is 1, 1 into minus P is minus P on this side will become plus P. In this way we have got vector equation of plane. So this is vector equation of plane in which form? Normal form. In normal form. In this way we have got the required vector equation of plane in normal form. Now we will try to convert this vector equation in Cartesian form also, and even we will discuss some important result which we are getting here. So now to find out Cartesian equation of a plane, first we are finding value of N cap in Cartesian form. Now LMN are what? Direction cosines of normal. If LMN are the direction cosines of normal, then unit vector along the normal. Already the unit vector along this normal is denoted by what? N cap. Then what will the value of N cap? Li cap plus mj cap plus nk cap. If we are finding its magnitude, what will get? Under root L square plus m square plus n square. But L square plus m square plus n square is 1, and value of root 1 is what? 1. Means value of this Cartesian representation means magnitude of this vector is 1, that's why we can say that it is unit vector. Means whenever direction cosines are given to us, we are able to find out unit vector of that line. Here what are the direction cosines of normal? L, M, N. That's why we can say that this is the unit vector along the normal. So once the value of n cap is known to us, if we are substituting value of n cap here, and r bar is what? Any point on the plane, and generally value of any point on the plane is defined as what? Xi cap plus yj cap plus zk cap, isn't it? X, y, z are coordinate of any point, so r bar will be xi cap plus yj cap plus zk cap. Now on the left hand side, we have to take the dot product of r bar and n cap. Value of r bar is also known to us, n cap is also known to us. Whenever two vectors are in Cartesian form, dot product can be found out as what? First take the product of coefficient of I cap, then j cap, then k cap. So what we'll get here? L into x will be Lx plus m into y will be equals to what? My plus n into z is equal to nz. On this right hand side, p, keep it as it is. In this way we have converted this vector equation into Cartesian equation. To apply this formula, we will require LMN, means direction cosines of what? Normal. Plane को direction cosines नहीं होते, line को होते, and in this case that line is nothing but what? Normal to the plane, and p is what? Distance of the plane from the origin. If these values are given to us, this formula can be applicable to find out what? Cartesian equation of plane. Now here n is what? Foot of perpendicular. Let us try to find out coordinate of foot of perpendicular if distance of the plane from the origin is what? P, and this on is nothing but distance of the plane from the origin is p. At that time we are discussing what are the coordinate of what? Coordinate of this foot of perpendicular n. So now this is the value of what? On bar. So means n cap is multiplied with what? P. And what is the value of n cap? Li plus mj plus nk. If I am substituting this value of n cap here, और ये पूरे टर्म को कौन मल्टीप्लाई? P मल्टीप्लाई. P से अगर इसे मल्टीप्लाई किया तो क्या मिलेगा हमें? PL I cap plus PM J cap plus PN K cap. Such type of result we will get if we are multiplying by P to what? N cap. This is the value of N cap. And we know that coefficient of I cap, J cap, K cap are nothing but coordinate of that point. In this case, that point is nothing but what? Foot of perpendicular. Means what is the x coordinate? PL, M coordinate, Y coordinate is PM, and Z coordinate is PN. So using means in this way we have got the coordinate of foot of perpendicular. Okay, so these are all important results which we are getting from this theorem.